All right, everybody, and welcome to the Daily Space Weather. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. And as we await a major coronal mass ejection impact, the filamentary frenzy continues as we've got huge plasma filaments all over the Earth-facing portion of the solar disk. The likelihood of additional coronal mass ejections, possibly more that are earthly directed, is quite high. Huge filaments there rising up over the eastern limb, possibly some new active regions rising. We'll have at least one new named sunspot group, I think, today. We've already gotten into geomagnetic unrest before any coronal mass ejection impact strikes the Earth's magnetosphere. Here's the northeastern limb. Note the huge filament south of the Earth scale there. That huge dark feature, this one right here, stretching all the way out of the view there to the west. That is a huge filament indeed. We've also got the northwestern limb. By the way, these are all 24-hour videos reflecting the SDO wavelengths of 193 and 304 angstroms. Filaments, filaments, filaments are the real story in terms of solar activity. Sunspot activity and X-ray flux not so active, but lots and lots and lots, probably something like trillions, maybe quadrillions of tons of material there suspended in the solar corona, defying the gravity, the massive gravity of the closest star. You can see a huge filament here, and these filaments, many of these do have names. Just follow the hashtag #NameThatFilament over on Twitter if you'd like to name filaments after living people. There may be some new ones to name today. We'll get to the breakdown of the filaments a little bit later in the video. There's the southeastern limb, and let's take a look at sunspots briefly here before we move into some information about what's going on here on Croissant Earth. So there is your SDO intensitygram. I think only one new named sunspot group today, this one right here. There may be one actually south of this new sunspot also. So there may be two new named groups today. We'll show you high-res imagery before we get to the meteorology segment about that. There's our SDO colorized magnetogram. That is yesterday plus today. And let's take a brief look at what's going on Croissant Earth. So today on April 23rd, we're interested in what volcanoes might be erupting. Subanose-jima starts out the list there with a 6,000-foot plume of volcanic ash. It's flight level 060. Mount Ibu also exploding. 7,000-foot ash plume over Halmahera, Indonesia. It's a flight level 070. Flight level unknown there over Semeru, although volcanic ash observed on Himawari 9 imagery. So Semeru also erupting. Dakono erupting, 7,000-foot ash plume. Popocatépetl exploding, flight level 200. It's a 20,000-foot ash plume over central Mexico. Guatemala featuring Sancha Guido and Fuego. Not sure if Sancha Guido is producing volcanic ash, but Fuego's produced a 14,500-foot plume of volcanic ash, flight level 145. Over Guatemala, and Sabancaya producing a 20,000-foot ash plume over Peru. Flight level 200, don't pole vault the caldera. Next, looking at global seismicity, there were a number of 5-magnitude quakes. There is a convenient 90-day bar graph to show you what's been going on recently. And let's check out the list here from the USGS site. We'll cite quakes over a 5 magnitude. Looks like things have calmed down on the California coast. There only one small quake showing up. Largest quake of the past 24, I believe, was this 5.8. This 5.8 at Indonesia. That one occurred at 1709, a universal time yesterday afternoon. There was also a 5.7 east of there near the banks of the Indian Ocean. Or I should say the shores. Also a 5.3 aftershock there in that same area. We also had a 5.1 at Tonga. That was at 2:28 this morning. And one more 5+. There's a 5.3 at the Philippines. And let's get back to space where the action is at. Again, there is a major coronal mass ejection about to strike Earth. We are expecting to see indeed the core of that coronal mass ejection strike the Earth's magnetosphere. We could see as high as a KP8 as a result of that. I'll say 7.66 is the maximum that we'll expect. And we've already seen geomagnetic unrest from likely coronal hole wind stream magnetic fields. So pretty interesting. And thanks for leaving comments, Mike and John. So there is the past 24 hours in SDO 171 angstroms. And let us know what your favorite wavelength from the SDO is in the comments. Is it maybe the blue 335, or perhaps, I don't know, perhaps maybe 211 is your favorite because it shows coronal holes. This is 193 plus 131 angstroms. The two best wavelengths from SDO to show plasma orienting to magnetic fields. So you may see things that look like potential field surface source lines there, magnetic field lines, and indeed that is what you are seeing as plasma aligns to the strong and coherent solar magnetic fields. The 10.7 centimeter radial flux, by the way, is now down to 141 solar flux units. And there is a one-year graph to put that in context. 141 solar flux units is the current state of affairs. Seeing a dip in both the sunspot number and the radial flux here at the moment. Continuing on to our space weather enthusiast dashboard, NOAA is expecting the CME impact to happen just before midnight tonight. Now that was our initial guess. When we first forecasted this CME, we were expecting it to arrive just before midnight. Watch our video from a couple of days ago. We indeed did forecast it to arrive around the same time NOAA did. NASA forecasted it to arrive a little bit earlier. So NASA's expecting it to arrive at any moment here. And again, I believe what we're seeing at the moment is a coronal hole high-speed stream. You be the judge. Let us know in the comments what you think. We'll get to the real-time solar wind here in a minute. First, let's take a look at Earth's magnetic moment from space. And you're going to see an uptick here reflected in the Geospace Magnetosphere movie. An increase in the magnetohydrodynamic pressure just came through in the past few hours. And that is a result of a major shift in the magnetic field. So you should see some big variations here happening in the second half of this Geospace Magnetosphere movie. Again, this reflects the past 4 hours of likely magnetohydrodynamic pressure around the planet. We are just on the verge of geomagnetic unrest at the moment. So there may be some aurora that are sparked here as a result of this. That's the likely locations to see aurora at the moment. This is the past 4 hours of Earth's magnetic moment from the ground. Our ground magnetic perturbations map. And you could expect to see this light up big time when that CME impact hits. We'll also show the full global view now that we've showed North America. Here are the past 4 hours of ground magnetic perturbations on a global scale. This will show you the most likely places to see pipeline, railway, and power grid induction, like telluric currents, for example. And don't be surprised to see the aurora very far south as a result of the nearly perfectly earthly directed coronal mass ejection. Now, just a consumer tip here also. There are some other features that you can view at the Space Weather Prediction Center. One of the great ones is just a minute here. The geoelectric field. So that's a great one to check out if you've never seen that before. You can actually view the geoelectric field. This will actually show you empirical data about how much induction is happening. And keep in mind, this happens instantaneously, so there's no warning. Before you get an update about the KP index, this already happens. So this is a reason why you must be prepared beforehand for coronal mass ejection impacts by doing things like watching our channel, as by the time the warnings show up, it is far too late. I mean, magnetic fields are moving around at the speed of light, and so, again, this induction into the power grid, which is depicted here as millivolts per kilometer, That is instantaneous when the plasma from space arrives, inducing currents in Earth's magnetosphere. So here we are at KP 3.66, just on this side of geomagnetic unrest, and that we could see some major enhancements here. Don't be surprised to see the KP all the way up here at KP 7.6. So major geomagnetic storm likely. And it could affect the U.S. power grid, as it is somewhat expected to arrive relatively shortly. So, of course, there is always conjecture about how fast a CME was moving. So let's take a look at the real-time solar wind, which shows us the feature which caused the recent uptick in the Earth's magnetosphere, Earth's geomagnetism. And it is this top pane right here. So this top pane is what I want you to look at the moment. Not only did the field increase, which is this white line, to about 11 nanotesla, but this red line went well into the negative territory. That negative BZ, that's the vertical component of the magnetic field, measured out at Lagrangian 0.1. And when we see a negative BZ, it creates a lot more induced current. In other words, material is pulled into the Earth system, inducing current as opposed to bouncing off of it, which is what you would see with a strong positive BZ. If that red line moves into the positive territory, that's more of a push, and the negative territory is more of a pull. So that's the way that works, and current conditions are quite chill here still. So just under 4 protons per cubic centimeter for the solar wind density. Solar wind speed here, 369 kilometers per second. And if that is a coronal hole high-speed stream, that's a pretty weak one. Again, we can expect to see a major signal from the incoming coronal mass ejection. So here we see some spikes going on in the GOES magnetometers, a little bit of a divergence there following midnight local time for the GOES 18, which is this blue line. The N's and M's, those are noon and midnight local time for the satellites. And if you're wondering where those are located, they're in near equatorial orbits at about 23,500 miles of altitude. Next, we'll look at the heliospheric current sheet, and Earth is right in the middle of a south pole-oriented current sheet depicted here in red. No changes expected to come anytime soon with that. Let's take a look at the line of sight field plot. There's the sun's B field depicted in blue, north solar polar field in green, south in red. And next we'll look at coronal holes, a super important feature as it depicts the solar polar field reversal cycle, probably the most important feature of a solar sunspot cycle. In other words, the polar field reversals are probably more important than the sunspots themselves, which many of us are believing is sort of an after effect of that solar polar field reversal process. And if you want to read about our CRAPF theory, CRAPF, C-R-A-P-F theory, become a gold member at the Smash Team. Details toward the end of the video on that. So that's the situation with coronal holes. We've got a bunch of South Pole-oriented coronal holes facing the Earth, a massive number of filaments, and kind of a low number of sunspots. Here are some good wavelengths to view coronal holes. That is 211 plus 171 angstroms. And you can see a trans-equatorial coronal hole here rotating in toward the Earth-facing portion of the solar disk. As Tamitha Skov would call it, the Earth strike zone, as a solar storm is on the way. And let's look at sunspots next. So here's a sunspot situation. We are expecting 1 or 2 new small sunspot groups over here in the east, both north and south of 3285. Besides that, no major changes. And and by the way, 3282 is now becoming very likely to produce X-class flares. So as that approaches the limb, also these areas are more likely to produce large flares. So look for large flares, especially on the western limb here. And as time goes on, as those get closer to the edge of the sun, you can expect to see larger and larger flare potential. Here is the SDO continuum plus 131 angstroms to highlight the active regions. And let's zoom in and drop 131 angstroms. So there is just the SDO continuum by itself. Those groups have been quite stable over the past 24 hours, the time period depicted in this custom helioviewer.org movie. We'll also talk about energetic particles and solar flares, which is interesting because we had an SEP, that is a solar energetic particle event. It was pretty minor, and it arrived just after midnight local time yesterday morning, and it's been going up ever since. Let us know in the comments if you think if it's leveled out. And it didn't really cause any major issues. By the way, this can cause polar HF radio blackouts. If you want to follow that, another thing that happens immediately. Once those particles arrive and start emitting radiation, follow the deabsorption predictions, or DRAP, and you can follow that yourself. So there are the deabsorption regions. You'll see equatorial radio blackouts caused by solar flares. Those are attenuating the ionosphere. And when you see polar radio blackouts, those are typically from solar energetic particle events, or SEPs. Again, at the moment, these sunspots have been underperforming a bit. The flare profile not super high. Just giving you some ideas of what you can watch when you're trying to monitor space weather yourself, as we're endeavoring to make all of our viewers into space weather experts. We need more people analyzing space weather and cosmology. There we have some minor polar radio blackouts likely there, as those proton flux levels get a little bit higher. Some, especially at the North Polar region, not a surprise there, as it is spring in the northern hemisphere. Anyway, moving on to the X-ray flux, again underperforming here. We've dropped back into a B-class background range. It's been pretty flat since yesterday, only a couple minor C-class intensifications there in the X-ray flux. Here's 94 angstroms for the past 24 hours. One of the better wavelengths to view solar flares there from SDO. Again, there is certainly a very high potential for flaring. The most likely spot would be right here. That's number 1. Number 2 would be down here. And number 3 would be over there. Those are the places to watch for large solar flares, especially on the western limb. And let's take a step back and talk about basic survival. Congratulations on surviving a global scamdemic so far. You've been doing a fine job. And thanks for tuning into the Smash News Network, Least Busted Name in News. One of the ways we enhance the possibility that these videos will continue to exist, remain publicly visible, and free for all to view is by selling merch. We make a tiny percentage of this, and we're just putting it out there for your amusement. It's also for our amusement, as we wouldn't put out products that we wouldn't personally use. By the way, some more interesting storefronts coming to the channel very soon. Anyway, Smasher Price, my first scamdemic. Congratulations on surviving one so far, as mankind tries itself to self-destruct over some things that, well, we talked about the actual danger of them all the way back in January of 2020. If you were unable to see the content back then, we aren't surprised. I'm sure it's not a coincidence. Once again, congratulations on surviving your first scamdemic so far. Links below the video to the Redbubble shop, and let's take a look at what's going on in space. So this is what's going on overhead over Lehigh Valley, Pennsylvania. We've got Saturn up there in between Aquarius and Capricorn, which that means something to somebody. Maybe it's in Aquarius, I don't know. We've also got a tiny sliver moon there, very close to Venus. So the moon and Venus very close together. Check the early evening sky just after sunset if you've got clear skies, as it's a great night to be out looking at the sky, especially to the north, with the impending coronal mass ejection impact. Next, a solar system forecast. We like our viewers to be oriented as to what's going on before we show coronagraphs, because, well, there's a huge difference between if the sun emits a CME in this direction than if the sun emits a CME in this direction, right? So that's why we show the solar system forecast. We are in a gas giant free side of the solar system at the moment. Let's advance this 1 week for your viewing pleasure. Here's where things will be in a week. And number 1, I order you to refrain from taking a number 2 in your pants. Engage. Next, coronagraphs from yesterday. And there were some CMEs, coronal mass ejections. Were they earthly directed? The answer is we don't think so, based on the available data. That is 103 frames from yesterday. Here are some more frames from today. Let's take a look at stereo A also here. We'll show the Soho-Lasco C3, along with stereo A, Soho-Lasco C3 on the right, stereo A on the left. Again, we do not anticipate any of these coronal mass ejections to be earthly directed. In fact, they are somewhat from the far side of the sun here, as far as we can tell. So here's a 24-hour video featuring 193 angstroms, the Soho-Lasco C2 in red and C3 in blue. Let's get a little closer. Just basically light shows, and you won't really see any activity on the Earth-facing portion of the solar disk. So typically, if these CMEs were more in the earthly vicinity, you would see some kind of movement, typically some kind of plasma moving around in 193 angstroms, but you don't, an indication that those are not in the earthly realm. Here's 193 angstroms all by itself. These are all 24-hour videos. And let's talk about filaments. We started out talking about filaments. There is one about to crash into Earth's magnetosphere at like 13 to 1600 kilometers per second. And check out the Filament Fest as it continues. Again, if you want to name filaments, follow the hashtag #NameThatFilament on Twitter. You can't name them in the YouTube comments or on the BitChute comments. If you're viewing the videos on BitChute, make sure you view on YouTube. You're missing like 90% of the content. Also check our playlists. There are videos that have nothing to do with space weather. And yeah, those are indeed a lot of filaments. Here's one of the ones that's like starting to look unstable here. That one could be in the process of ejecting as we speak. That's the ground-based Hydrogen Alpha telescope at El Teide, Spain, part of the National Solar Observatory. Follow us all over the internet at SmashOmash. And here is the past 24 hours in the classic ionized helium, 304 angstroms wavelength from SDO, with the great high-resolution imagery there. And let's switch to the past couple of hours here from the GO 16 SUVI. Let's zoom in briefly here on that filament. So there is certainly some movement happening down here. That could be a coronal mass ejection in the making. It could also end up producing a flare, as we're becoming more and more confident that solar flares are produced by plasma motions, not vice versa. Anyway, let's shrink that down to a full disk size. Oh, and by the way, there does appear to be additional activity rising over the eastern limb. There's a lot of plasma suspended out there, and that is typically a feature that you would see with active regions and sunspots. Anyway, here is the full disk imagery that we stream regularly to the Twitch channel at twitch.tv/SmashOmash. And that brings us to our bonus feature segment. First thing we'll look at is charging hazards for satellites. And at the moment, we do have some significant surface charging hazards here moving into the central Pacific Ocean. That could cause some minor communications difficulties with near equatorial satellites. Some surface charging there caused by low-energy electrons building up on the outsides of satellites there over the Pacific Ocean. The GOES electron flux here remaining kind of low, and we're expecting this to remain low here. Let's see what NOAA has to say about it. There's the NOAA forecast, and they are expecting the trough to continue. We're in the longest extended electron deficit here for the past year. If you think that means doom and destruction, it just doesn't. There's the one-year graph to put it in context. We did have a little bit of an uptick there. But as you can see there from the one-year chart of the greater than 2 megaelectron volt electron fluence, that we just came out of the lengthiest electron trough in the past year. That electron flux is measured at the F layer of the ionosphere, one slice of the thermosphere there at about 300 kilometers of altitude, denoted by that red F. Feel free to pause the video on this frame if you're not familiar with the temperatures of areas like the thermosphere, stratosphere, mesosphere, etc., electromagnetic radiation penetration, and thermospheric chemical compositions. Here is the F layer of the ionosphere. And we are expecting to see some major shakeups in the ionosphere as a result of a major coronal mass ejection impact. Should be interesting in tomorrow's video. This is the vibrational frequency of that one slice of the thermosphere, the F layer of the ionosphere, at about 300 kilometers of altitude. Here's the anomalygram as well, showing anomaly in megahertz from a 30-day median. And again, we can expect a rather major shakeup here. In fact, we're already seeing a major shakeup. Huge number of low-frequency anomalies here. We'll let that play through a second time. Lots of red there. Low-frequency anomalies. And there's the latest image, 1300 universal time ionogram and 1300 universal time anomalygram, coming at you a little bit later than normal today as we had to do some upgrades. We'll also show the total electron content. That's the free electrons up to about 12,500 miles of altitude, the location of your GPS satellite. Feel free to pause the video on this frame. Here's your total electron content forecast. And this will show you the most likely places for GPS errors. It's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Free electrons between about 12,500 miles of altitude and your GPS handset. We'll finish out the space weather segments of the video by looking at the latest intensitygram at high res and the latest colorized magnetogram. So let's check for new sunspots around the east. So there is one south of that sunspot 3285, I believe it is. So there's a new one right there. And then north of it, there's also another new one. So we expect two new named sunspot groups today, a small uptick in the sunspot number. And unless those suddenly grow, probably a further downtick in the radio flux as we've got setting groups approaching the western limb. Anyway, here's your full disk rock back. And let's move to meteorology, transitioning from the space layer of nullschool.net. That strong vertical component of the magnetic field, that strong negative BZ that we talked about in the real-time solar wind data, indeed inducing some current. So a perfect example of how you can just see a magnetic field shift and aurora be sparked as a result of that. Again, also keep in mind this happens basically instantaneously, at least instantaneously from the perspective of human time frames. There are the aurora australis, and here are the aurora borealis. And let's switch to our regularly scheduled surface winds and jet streams. We'll start out with the eastern world's surface winds. And here are the eastern world's jets. Europe, Africa, and the Middle East's jet streams depicted here. Surface winds depicted here. And last but not least, the Americas. It's still stormy in the North Atlantic. A low just hanging out there between Newfoundland and the Azores. And these are the jet streams, doubled up jet stream over the Gulf states there. And indeed some severe weather forming over Texas. We'll get to it. There is, shall we say, a large cloud. It's about the size of Ohio. That's recently formed over southern Texas. You'll be able to see it showing up there on the map. That is indeed a huge, possibly supercell. So that's clouds and fog over the Americas. Here's your weather.gov map. And if your location is lit up, click your location. Those are hard freeze warnings and frost advisories, I believe. So some hard freezes coming to a large portion of the central U.S. Weather.gov, click your location if you've got warnings. Next, some forecasts, starting out with your temperature anomaly in degrees Celsius based on the 72-hour GFS model. Most of the eastern country here expecting colder than average temperatures for the next 3 days. We've also got pressure and precipitation. And again, we talked about it yesterday. That is a very strong cell forming there over Texas. And it's going to just get stronger as it approaches the high potential energy convective systems that are located in the hot water Gulf of Mexico. Yeah, the Gulf of Mexico. Some thunder snow likely coming to Colorado here. So all the hot air coming out of that state not likely to prevent that from happening. And just a quick reminder, mankind is unable to control the weather and the climate, except on tiny scales. Suggesting that mankind is able to control the climate and the weather on large scales is the pinnacle of ignorance and indeed arrogance. This is the 72-hour GFS pressure and precipitation forecast. And let's move on to our windy.com map. And just give that a minute to initialize. In fact, I'm going to press refresh. Just bear with it. Give it a minute to load. As that indeed is a... Come on, then. Clear off. Please show the satellite. There we go. So check out the size of that cloud. That is a dark cloud indeed. And you can see, hey, check it out. Gravity waves there forming at the top of that cloud. Gravity waves, folks. It's, wow. That is indeed a major weather system forming over southern Texas. So we also had some extreme lightning. There's our lightning mapper. That's the past about 10 hours. And Texas was definitely the lightning capital of the U.S. over the past half a day. So here's a real-time lightning map from lightningmaps.org. And indeed, we already have significant thunder and lightning happening west of Houston and south of San Antonio. Wow! So be aware of those systems and how they'll be moving to the southeast. If you've got images of those clouds, if you've got ability to take video of those cloud tops especially, please do. Wow, that is a serious cell. Check out all the lightning. That is pretty berserk. And next time you hear thunder, we encourage you to check out lightningmaps.org. And here's the current situation, U.S. Doppler radar there. We'll briefly zoom in on this system. You can see a very, very, very strong system right here. Keep in mind, folks, tornadoes in the northern hemisphere are most likely to form in the northwestern portion of a system. And that's kind of moving right down the Texas-Mexico border. Nuevo Laredo is in the crosshairs as that system slowly moves toward the Gulf. Here is clouds and fog. That's 3.9 micrometer infrared radiation. And there is water vapor. You see that rapid cloud nucleation happening there. A lot of evaporative and convective processes happening there in southern Texas. Here's your recap. U.S. Doppler radar. Clouds and fog. Which, by the way, this is great to help you figure out if you'll be able to see the aurora or not. Of course, the ability to see stars also works. And last but not least, there is your water vapor map. And it's time to close this thing out. By the way, thanks for tuning into the Smash News Network, least busted name in news. If you enjoy the content, press like, subscribe, share, etc. Maybe tell your friends and foes about the content, and maybe visit us on our home sites. SmashOmash.com/SmashTeam is the site on which to support the channel. If you prefer the content to remain existent, publicly visible and free for all to view, consider becoming a member of the Smash Team, especially at the gold or silver level. The best value is the gold annual paid-up subscription. Thanks to everybody who has brought you these videos. They are brought to you in part not only by Smash staff and I at massive personal risk and expense, but also the Smash Team. SmashOmash.com/SmashTeam launched in October 2021. It's our subscription services site. We are still on Patreon and PayPal, and we've also got the Hemp Lucid links and so on, so make sure you visit those as well. If you are in the market for some CBDs or mushroom gummies or other products available from Hemp Lucid, check it out. The 420 sale continues while supplies last. Save 40% on many purchases. And don't forget to enter the promo code SMASHOMASH to save some cash on checkout for your Hemp Lucid purchases. Link below the video and on the homepage of the Hemp Lucid shop. And if you're unable or unwilling to open your cobweb-encrusted wallet, consider supporting the channel via clicks from SmashOmash.com. It's our homepage, and by the way, welcome to the Neo-Renaissance. Congratulations on realizing the channel exists. It's time to close this thing out. Once again, thanks for tuning in. In the meantime, I'll have been your host, Dan, a.k.a. SmashOmash, signing off. Awaiting a major geomagnetic storm and coronal mass ejection impact. In the meantime, may that solar wind be at your back.